In this video, I will explain how to calculate the present value of an ordinary annuity. So here's the formula. We say that the present value, PV, is equal to A times 1 minus 1 plus R to the power of negative N, all divided by R, where A is the payment at the end of each period, R is the interest rate per period, and N is the number of periods. Now keep in mind for ordinary annuities, the payments occur at the end of each period. But for annuity due, payments occur at the beginning of each period. So for this example, we're talking about an ordinary annuity where the payments occur at the end of each period. So keep that in mind. So let's check out an example of how to actually use this formula. This example says how much should Linda invest now in order to generate a cash flow of $3,000 at the end of each quarter for 7 years at an interest rate of 8% compounded quarterly. So we're trying to figure out the present value. How much should Linda invest now in order to be able to generate this cash flow for 7 years? So to figure out this present value, we can just use this formula right here. We'll say the present value is equal to A. A is the payment at the end of each period. So we're told Lisa wants to receive $3,000 at the end of each quarter. So 3,000 is the number we'll use for A. Then we're multiplying that by 1 minus 1 plus R. So R is the interest rate per period. Now in this example, we're told that she will be investing at an 8% interest rate compounded quarterly. So 8%, this is the annual interest rate, but since we're compounding quarterly, remember there are 4 quarters in a year. So the interest rate per period, that's going to be 8% divided by 4. So as a decimal, 8% is 0.08. So if we do 0.08 divided by 4, that turns out to be 0.02. So that's what we'll use for the R, for the interest rate per period. So let's write 0.02, and then we raise that to the power of negative N. Now N is the number of periods. So remember, Linda wants to generate this cash flow for a total of 7 years, and she wants that cash flow each quarter. So up here, let's write N, the total number of periods, 7 years times each year there are 4 quarters, so 7 times 4 is a total of 28 periods. So she wants this cash flow for 28 total periods. So in our formula, when we raise to the power of negative N, that's negative 28. And then all of this will be divided by R, which R we found was 0.02. So this is the formula that we're going to use to figure out this present value. We just need to simplify it a bit, so I'll go ahead and write that out. So if you multiply those values out, you find that it comes to $63,843.82. That's how much Linda needs to invest now in order to generate this cash flow of $3,000 at the end of each quarter for 7 years at an interest rate of 8% compounded quarterly.